All right, for the last thing we're going to look at is when we have a gas not at STP. When you have a gas not at STP, you can't just use that 22.4. You actually have to use PV equals nRT once you get to moles. So it's the same three steps, just on the third step here, when we're going from moles to liters, instead of using a conversion factor, we're going to use PV equals nRT. So we're going to start with our 1,000 grams of calcium carbonate, and we're going to get this to moles by using the molar mass of calcium carbonate. And I'm just throwing that in a calculator because I don't do math in my head. And it's 100.09 grams. Then I'm going to use a mole ratio. For every 1 mole of calcium carbonate, I'm going to get 1 mole of CO2 gas. And I'm going to put this in my calculator, and I solve that I'm going to get 9.991 moles of CO2. Okay, so now from here, I'm going to use PV equals nRT. The pressure we were given is 2 atmospheres. The volume is what we're looking for. N is what we just calculated up here. And R is always 0.0821. And the temperature we were told is 500 Kelvin. Now, it's really important when looking at a problem to look to see if you're changing substances or you have just one substance. Because if you just have one substance, you can go straight to PV equals nRT. But if you have 2 different substances, you first have to use stoichiometry to convert to your new substance. So now I'm going to plug this into PV equals nRT. So I'm going to have 2 times X equals 9.991 times 0.0821 times 500. I'm going to put this all in my calculator. And I get out 205.1 liters of CO2. Okay, so when you have a gas that's not at STP and you have to convert between substances, you're going to use PV equals nRT.